Hello, very good evening, guys. Welcome to the faculty level platform that is Resultant. Very good evening, all of you. How are you all? I hope everyone is good, fine. So today in this session, I've started a new series for you guys, and in this particular series, we will be taking up some questions, and from those questions, we'll be trying to understand the concept behind the logic. Okay, fine. So first subject that I'll be taking is industrial engineering, and I'll be having 3 to 4 sessions on this, where we'll be solving some PYQs, and that too a good level of PYQs, and from those questions we'll be able to understand the concept behind that particular topic. Okay, and today's topic is inventory models, very important. And you might have seen that if you have taken the analysis of the GATE paper, every year or every alternate year you are expecting at least one question from this topic, and that too you are expecting from the basic EOQ model. Okay, so it's very important you try to revise the topic, you try to understand the logic by watching these session, and it will be a very short session, 20-25 minutes of session, where we'll be solving some questions, right? And from those questions we'll be learning the concept. Okay, chaliye. So before starting the session, please do let me know whether my audio and video all good, all perfect. Yes, very good evening. Yeah, all good. 1 second. Yeah, chaliye. 1 second, let me check. It's all good. One second, guys. Okay, all perfect. Fine. So you might have know that we have already launched this platform last month, right? And definitely now you are in that particular stage where you are preparing for the GATE and a different examination, and where you want to have a consistent we can say sessions, and for that only we have taken up this new initiative, that is faculty level platform, that has resulted, right? And before starting the session, please do like the session and do subscribe to this channel for more such awesome videos on your footsteps, or we can say for easy access. Okay, this is my personal Telegram channel, that is Mechanical by Suraj, where you can do connect with me, or if you have any doubt or difficulty, please do not hesitate to drop me a mail, so that I can help you to guide for this GATE and ESC journey, right? So if I talk about inventory models, basically, if I talk about inventory model, there are two major classification of inventory models that we are calling it as the deterministic models and the probabilistic model. Okay, so if I talk about what is the major difference between deterministic and probabilistic model, if I talk about deterministic model and the probabilistic model. And a very important thing that I need to tell you is entire industrial engineering is nothing but a mathematical tool only. Okay, it's a mathematical formulation where you need to understand the logic and apply that logic to the different numericals. If you are preparing for GATE examination from industrial engineering, you will be only getting the numerical based question. That's it. Theory question not at all possible, because this is entirely a numerical based question where you need to understand one logic, apply that logic to different conditions. Okay, so deterministic model or probabilistic model, the major difference between these two is, by the name itself we can say, in deterministic some parameters will be constant, and in probabilistic the parameters won't be having a fixed value, it will be a variable. So here if you try to visualize, in deterministic model we can say the demand rate and the lead time, both are basically the constant value, right? But if I talk about probabilistic model, the demand rate and the lead time, or any one of the parameter, will be a variable value, right? Okay, understood. Now we need to understand what is demand rate. Now let us suppose there is a, let's say this takes an example of this pen. The annual demand of this pen is, let's say, 10,000 units. Okay, let us suppose I'm denoting capital D as annual demand. And I'm assuming that this annual demand is for this pen is 10,000 units per year. That means this is the annual requirement of this pen in our inventory. Okay. Now the question is, if I want to convert this into, let us suppose, per day basis, that means how much will be the demand rate for one day or for 1 week or for 1 month? How we can calculate? We can simply divide 365, 10,000 divided by 365. That will be giving you the number of units required per day, or consumption rate, or demand rate. Okay, so it is not always mandatory that the demand rate will be defined per day basis or month basis. According to the questions, you need to check the units. And very important, in inventory models, you have to understand, you have to see the units carefully, because sometimes what happens is they are giving the demand rate in per week and they're asking the final value in days. So you have to convert the conversion from year to days or year to week, right? That you should be knowing, because we know that 365 days in 1 year or 52 weeks in 1 year. So that conversion unitary method you should be knowing. Now, so now we have understood what is demand rate, and demand rate is normally denoted by small d, right? And lead time is LT. Now, what is this lead time? I'll be explaining you by taking one question, right? And from that question, we'll be able to answer. Okay, or we can say by taking one example, we'll be able to understand. Now, if I talk about deterministic or probabilistic model, there are basically 4 deterministic models that is there in your syllabi. We are having simple EOQ model, the EOQ models with discount, EOQ models with shortage, manufacturing or production model. If I talk about probabilistic model, where the demand is a variable term, we are having perishable or spare items, spare parts. Definitely we'll be seeing in the later on stages. In today's session, we will be concentrating on these 2 models, simple EOQ and the EOQ model with discount. I'll be taking one example each, so as you will be able to understand this in detail. Okay, fine. The simple EOQ model is also called as the infinite replenishment model. What is the meaning of this infinite replenishment model? Let us take one example. Now we know that your this one deterministic model, the demand rate will be constant, the small d will be a constant value, right? And there is one term that we are seeing, EOQ, is very important. Entire inventory will be revolving around this term. EOQ basically, can anyone who can tell me what's the meaning, what is the full form of this word EOQ? Anyone? It's a very easy and very important. If you have studied the industrial engineering, or if you have a basic idea, you will be able to answer to this question very easily. EOQ basically stands for economic order quantity. Okay, what is the meaning of this word economic order quantity? Economic order quantity means, let us suppose, if I want to buy an inventory, let us take an example of let's say rice. Okay, let us suppose 1 month 10 kg rice is required at your place. Okay, 10 kg rice is required for 1 month. Okay, so there is one feasibility that you can purchase the entire 10 kg rice in 1 day and you can consume for 1 month, or you can purchase on daily basis some grams of rice. Okay, there are 2 possibilities. Every day you will be going to a shop and will be purchasing some grams of rice, because you have to cook rice and eat. On the other hand, you can go on the first day of the month and you will be purchasing 10 kg rice, and that 10 kg rice you will be storing and you will be using slowly for entire month. Okay, in both the cases, the cost that is being associated, the total cost that is being associated, both the cases will be different, right? Because if I take the first case, in the first case there is no holding cost that will be accumulated, because you are only purchasing that much amount of rice that is being required to cook and eat. But on the other hand, when you are purchasing the 10 kg rice on one go, you have to store in a safe place, because if you are just storing that rice in an open place, might be the insects will be coming, might be the rat will be coming and will be eating the rice, and that entire lot of rice will be completely destroyed. Okay, so you need to have a proper storage place. Holding cost will be associated, but you only have to go one time to purchase, so that transportation cost or cost of ordering will be only one time. On the other hand, in the first case, when you are purchasing rice on daily basis, you have to might be you'll be using a two-wheeler or you'll be taking a rickshaw. So that transportation cost or the cost associated for ordering that material will definitely will be on daily basis. So overall, what is the meaning of economic order quantity is, it is that level of inventory or that size, order size, at which the total cost associated, total cost means I'm talking about all the cost that is being associated, that will be the purchase cost, that will be the ordering cost, that will be the holding cost, that will be your shortage cost, every single cost that is be associated. If you try to add and if you are getting that cost to be minimum, that particular lot size at which the total cost is minimum, that particular we can say inventory, we call it as economic order quantity or EOQ, right? Or in simpler words, we can say economic order quantity means that lot size at which the total cost is minimum, right? That lot size at which the total cost is minimum. In our inventory concept, in our inventory model, there are basically 4 to 5 different costs that is being associated. But in basic EOQ model, if I talk about basic EOQ model, only 3 costs we are coming across. One is purchase cost, ordering cost, and holding cost. I'm not going to that derivation, right? If we're going to the derivation, that this session will be extended for at least 90 minutes. Okay, we will be taking each and one example. So I'm giving it a very short, crisp manner. In basic EOQ model, no shortage is allowed, right? And you will be having the purchase cost, you will be having the ordering cost, and you will be having the holding cost. There will be 3 costs that will be associated in the basic EOQ model. What is purchase cost? That is equal to annual demand into unit price. C is the unit price. Let's say this pen is costing me 100 rupees for 1 pen. If you want to purchase 5 pen, so 5 into 100, 500 rupees will be the purchase cost. Okay, fine. Next, ordering cost. Ordering cost is nothing but the number of order placed into cost per order. N is number of orders, the number of orders placed into cost per order, right? Now let us take one example. Let us suppose annually you require 12,000 units. Okay, this is the annual demand. You guys gonna tell me. And every time you are placing an order size of, this is order size. You're placing an order size of, let's say 500 units per order. So can you tell me what will be the number of orders that will be placed? In 1 year, you require 12,000 units. One time you are placing only 500 units. So can we say the number of orders will be 12,000 divided by 500? That will be simply 6. We can say not 6. That will be simply 240. That will be simply 240, 24 units, or 24, not 240, 24. Clear? So that means you have to place 24 number of, this is number of orders per year, number of orders that you have to place in 1 year. So I can rewrite this equation as capital D by Q into CO. This is the ordering cost. This is very important. I'm making a block. This is purchase cost. This is ordering cost. The last one is holding cost. Now what is holding cost? Holding cost is the average inventory that you are storing for a particular time, right? Okay, so that formulation, I'm not doing the derivation right now. This is equal to Q by 2 into CH. CH is the holding cost per unit per time. So this is, CH means the holding cost per unit per year. Okay, what is CO? CO is the ordering cost. Okay, CO is the ordering cost per order. That means rupees per order. Rupees per order. That means for one order, how much cost you have to place. Now you have understood some basic idea about the EOQ modeling, and that too you might have understood that this entire thing is revolving around cost only. Okay, so in basic EOQ, because shortages are not allowed, so we will be only associated with three costs, that is ordering, purchase, and the holding cost, right? So now, if I try to calculate what is the basic EOQ, the first model that we need to understand, the basic EOQ model. Now, to understand this in detail, let us try to take one example so as to understand what is being given in the question, and from that what we can infer from that particular question, and from then we'll be able to understand the logic. Okay. Now, they are saying that a local tire distributor expects to sell approximately 9,600 steels belted radial tires in next year. That means, what is this being given? Definitely, Harsha. I'll be taking assignment problem also. No problem with that. What is this 9,600 being given? Can you tell me? Well, by reading the question, whenever you're having this kind of difficulty, always read the entire line. They're saying this much of tires in the next year. That means, can we say this is capital D? That is annual demand 9,600 units per year, right? And I'll be taking, Harsha, I'll be taking one session on simplex method also, because many students do text me, sir, simplex method is very difficult to understand. One numerical I'll be taking on simplex might be I think tomorrow or day after tomorrow. I'm not sure about the schedule, right? I'll be updating that on my Telegram channel. Okay. Now, annual carrying cost is rupees 16 per tire. Okay, that means, what is the meaning of carrying cost? Carrying cost means they are talking about the holding cost. So holding cost is given as rupees 16 for one tire, that is per unit, and they are talking about annually, so this is per year. You have to check the units, is very important. Sometimes what happens is they are giving the annual carrying cost or holding cost in per month, and if you're using that value, that will be giving you a wrong answer. So always check the unit whenever they are asking question from the inventory model. Okay, next is ordering cost is rupees 75 per order. Perfect. CO is equal to rupees 75 per order. Now they are saying that what is economic order quantity? Normally economic order quantity is denoted by Q star. This is your economic order quantity. Okay, that means the optimum level of inventory that I need to keep or that I need to place in order to get the minimum total cost. Now, to understand this, let us draw one diagram so that you will be able to understand this in very logical way. Now, we know that the demand rate is constant because this is a deterministic model. So, let us try to plot a curve between, on the y-axis we are having inventory level, that means how much inventory that I need to keep, and on the x-axis we are taking time, because with the time I have to see. Now we know that the demand rate is constant, right? That means, let us suppose if I say on daily basis, if I take the same example, capital D is equal to 9,600 units per year. Okay, so can you tell me on one day how much units will be required? So let us try to divide this by 9600 divided by 365. That will be approximately, if I try to calculate small d, that is equal to capital D by 365, that is somewhere around 26.3 units per day. I'm taking just this is not even required in the for solving that, only for making you understand. That means on daily basis 26.3 units is required, or we can say this is the demand rate. We can say this is the demand rate, or we can say consumption rate also. Okay, now because this demand rate is constant, we can say initially we had some value, and with the time it is decreasing and it will be reaching the zero level. Okay, if I try to take an example where we'll be having some integer value, right? Let us take annually we require let us suppose 3600 units or 3650 units per year. Okay, fine. And the demand rate will be 3650 by 365, that is 10 units per day is the daily requirement, right? Initially, this is the maximum inventory that we are having. This is the maximum inventory level that we are having. That is denoted as Q maximum. Okay. Now, initially we had some inventory. Okay, and with the time, with the consumption rate of 10 units per day, it is becoming zero after one particular time. So this particular duration of time, we call it as cycle time. This capital T represents you the cycle time. Capital T represents you the cycle time. That means, and that will be same for every cycle. What will happen when, as soon as this inventory is becoming zero, the next lot will be coming and the inventory is again full, and with the time it will again go like this, then again it will be moving up and like this. So this way our inventory basic EOQ model, in this way our basic EOQ model is basically being understandable. Okay, like this, because that x-axis was very small. Understood? Now tell me one thing. At this point the inventory is becoming zero. This is the max inventory. Now do I need to, let us suppose I'm having, let's say this is 1 month. Okay, this time cycle is for 1 month. So in 1 month we'll be having 300, I'm taking a reference, 300 units. I'm having 300 units initially. Every day 10 units is being consumed, and for 30 days it is coming to zero. After 30 days is coming to zero. Let us take an example. So tell me, on the 30th day when it is becoming zero, after that only do I need to place the order for the next lot, or do I need to place the order before reaching the last date, before reaching the zero line? Let us suppose at your home you are having, every day you are consuming rice. Okay, fine. And what happens once the rice is finished, then you are going to shop? Will that be an advisable, or you see that approximately 1 or 2 days stock for the rice is left out, you try to go to the shop, you bring that rice, and as soon as it is becoming zero, then again you will be refilling that particular container? That is advisable. That means I will be placing the order for the inventory much before it is reaching the zero level. So that level of inventory at which I am placing the next order, that we call it as reorder level, ROL. That is we call it as reorder level, ROL. Okay, fine. That means at this point when the inventory has reached reorder level, this is, we can say, we are placing the next lot. We are placing the order for the next lot. This is lot 1, this is lot 2, this is lot 3, and this way it is going on. And this cycle time will be, or this cycle will be continuously, it will be same only. This is capital T, this is capital T. This way this cycle time will be same. This is the reason we are calling it as deterministic model. So we are placing the order over here, we are receiving the next lot size. We are receiving the next lot over here. If you try to visualize at the end of the cycle, can you tell me what is the slope of this curve? Yes. At this point, at the end of this cycle, at this point when the cycle is being completed, one lot is being completed, what is the slope? The change in inventory, the change in inventory by change in time. The inventory changing from 0 to Q, okay, but time is not changing. So what is 1 upon 0? That is tending to infinity, and that is the reason we are calling this basic EOQ model as the infinite replenishment model. Are you able to understand? Everything that we have now studying, right, we are able to correlate. Okay, fine. Is this clear? So now you have understood that why we are calling this as infinite replenishment model, because you can see at the end of every cycle, the slope of this curve, that is the rate of change of inventory with respect to time, is tending to infinity, and this is actually happening at the end of every cycle. Okay, and the time taken for once you are placing the order and the inventory is reaching our system, our factory or warehouse, that time duration is called as lead time. Remember LT. Remember LT, lead time. That means it is that time duration. Once you are, let us suppose you are placing the order, today is Tuesday, you are placing the order on Tuesday morning 9 a.m. and you are getting the order on Friday 9 a.m. right? That means you are having Tuesday, Wednesday, Thursday, Friday, 4 days will be considered as the, not 3 days will be considered as the your lead time. That means the day on which you are placing the order and the day you are receiving the order, that time duration will be called as the lead time. Okay, clear? So now we have understood that the entire logic behind basic EOQ model. Now let us try to write what are the total cost associated with this basic EOQ model. That is, we are having all the cost that we are having in our inventory system, try to place in at one place. We are having the purchase cost, we are having the ordering cost, we are having the holding cost. Okay, so this is total cost is equal to capital D into C. C is the unit price, capital is a annual demand. Ordering cost is capital D by Q into CO. Holding cost is Q by 2 into CH. Understood? We are also calling this total cost as total annual cost. Okay, or simply we can call it as total cost. TAC or TC, both are correct. Now, if you try to visualize in this total cost, there are three. We are having the purchase cost, we are having the purchase cost, right? We are having the ordering cost, and we are having the holding cost. Okay, so tell me, among all the three costs or three costs that you are seeing on the screen, which cost is independent of inventory? That means annually you require 12,000 units. Let us take an example. Annually you require 12,000 units, and every time you are placing 1,000 units every time. Okay, so tell me, among all the three different costs, which cost is independent of inventory? Can we say that is purchase cost? Because in purchase cost, it is independent. You try to take 1,000 units, you try to take 500 units, you try to take 12,000 units. It is not depending. It is not at all depending. The purchase cost is not. It is independent of the order size. So we can say the ordering cost and holding costs are the only costs which are depending on the order size, that is Q. Right? Okay, so this type of cost which depends upon the inventory, that type of cost we call it as total inventory cost, TIC. This is called as total inventory cost. And what is our prime objective of studying EOQ? EOQ means that order size at with the total cost is minimum. So let us try to do one thing. In order to have this total cost to be minimum, let us try to differentiate this total cost with respect to Q and make it equal to 0. This is for minimum cost. For minimum cost. Now you try to differentiate this equation with respect to Q. The purchase cost will be constant, that will be 0. This is 1 upon Q, 1 upon X differentiation is minus 1 upon X square. Right? So by solving this, or let me try to add one slide over here. One second, guys. Let me add one slide so as to take the benefit of this. Yes. So we can say if you try to differentiate, so we'll be having minus D by Q square CO plus 1 by 2 into CH equal to 0. So rearranging the equation, Q square will be equal to 2dCO by CH, or Q is equal to root of 2dCO by CH. So this is the inventory size at which the orders, we can say the total cost will be minimum. So this is we called as EOQ, and EOQ is always defined by Q star. Very important. The entire other EOQ models are depending on this formulation, 2dCO by CH. Now coming back to this equation, this was asked in GATE examination. They are asking EOQ. They have given D, they are given CH, they are given CO. Place it and tell me the answer. Q star they are asking 2dCO by CH, root of this. So 2 into 9600, 75 by 16, root of this. Tell me what is the answer that you are getting quickly. Let us 2 into 9600 into 75 by 16. We are getting exactly 300 units. Option C. What's the meaning of this? The meaning of this is, that means if you are placing, the annual requirement is 9,600. I'll be drawing that graph also of this particular value. 9,600 is the annual requirement. Every time you are placing an order of 300 units per order. If you place 300 units per order, then your total cost associated with this will be minimum. And that is basically, we call it as the EOQ, that is economic order quantity. Clear? Hai? Understood? Let us draw the graph. The problem is done, but we will be understanding this more by taking one more discussion on this. Because we are talking about basic EOQ, this will be the diagram. Only one cycle will be drawing. Okay? It will be repeated like this. Now, tell me one thing. If 9,600 is the annual demand, okay, so what is the daily demand? What will the daily demand? Anyone? If 9,600 units is our annual demand, can we say daily demand will be equal to, divide by 365, that is 26.3. Acha, we have already calculated this, units per day. Okay, can you tell me, anyone, can you tell me, initially we are having 300 units, initially we are placing, because we already calculated Q star is equal to 300 per order. Okay, so tell me how much time will be taken to make this inventory from 300 to become 0. That means, what is the cycle time? Can anyone who can tell me what is the cycle time? How much time will be taken for one, or what is the duration for the one complete order? That means you are having 300 units. After how much days it will be becoming 0? Anyone? Simple unitary method. Can we say this will be equal to Q star divided by small d, because I'm calculating in days. So this will be equal to, this is 300 divided by 26.3, that is somewhere around how much? 11.41 days. What's the meaning of this? Let me write the complete days per order. That means one order will be finished in 11.4 days. So I can say in 11.4 days, your entire lot will be becoming from 300 to 0. Is this clear now? Understood? In 11.4 days, our 300 units order will be becoming 0. That means after every 11.4 days, we will be having the, we can say the order will be repeated. Okay, that we call it as cycle time. And we can denote this as, T star. Okay. Let us suppose if I want to calculate what is the number of orders being placed, quite easy. That is equal to capital D by Q star. Let us calculate, that is 9600 divided by 300, that is nothing but your 32. 32 orders you have to place in 1 year in order to fulfill our annual demand. That is the optimum. This N star and T star is called as the optimum duration or optimum number of orders. Clear? So based on the same logic, let us take one more example so as to understand this in a much more easier way. Now consider the following data for a product. The demand is given. So annual demand is given. Okay, very good, very good. Ordering cost is given. Holding cost. Now they are saying that holding cost is 10%. Whenever you are having this kind of data being given, कि आपको दे रखा कि percentage of some value. If nothing is mentioned, you always need to take the holding cost is equal to the percentage of the unit cost. The holding cost will always be the percentage of the unit price or unit cost. So I can say CH will be equal to 10% of unit cost is 500. So that is equal to 0.1 into 500, that is equal to 50. Okay, that is equal to 50 per unit per year. Okay, now they're saying that what is the time between orders in days for EOQ order? That means they're asking you about T star. Very easy. अब T star पूछा है, you have to calculate Q star. चलिए, so Q star will be equal to 2DCO by CH. Same formula. There is no change in this. So capital D is, what is capital D is given as 1000 units. CO value is 40. CH value is 50. Root of this, let us calculate what is the value of Q star. So this is somewhere around 40 units. 40 units per order. That means in one order, you have to purchase or you have to buy 40 units only in order to have an EOQ. Annual requirement is 1000 units. Now they're asking you what is the time between order. So obviously we can use the same formulation. T star will be equal to Q star divided by D. Right? Now they're asking in days. Capital D is in per year. So I have to convert this into small d. So small d will be equal to 1000 divided by 365. 1000 divided by 365 units per day. Okay, so let us try to place this small d over here. So it will be 40 divided by 1000 into 365. So that will be somewhere around 4 to 14.6. 365 14.6. Yes, 14.6 days per order. ठीक है? Fine, very good Negi. Perfect. So 14.6 is the duration of one cycle and this is being asked. अगर क्वेश्चन में इंस्टेड ऑफ डेज इफ दे आर आस्किंग ईयर, तब आपको सिंपली T star will be equal to Q star by capital D. This value will be getting in years. You'll be getting in year. If they're asking in days, then you have to use T star will be equal to Q star divided by small d in days. तो यूनिट्स का ध्यान बहुत रखना है बिकॉज इट डिपेंड्स इन द एग्जामिनेशन व्हाट दे आर आस्किंग. इफ दे आर आस्किंग फॉर 1 year, देन आंसर विल बी सिंपली 40 divided by this, that will be 0.04 year. That's it. Clear hai? Fine. So this is all about the basic EOQ model that we have seen. So already the time is up, right? I was planning कि भाई 2 मॉडल हो जाता, but ठीक है, कोई प्रॉब्लम नहीं है. We'll try to take more sessions so as to cover the more number of models. Clear? Done. Good evening. Almost we are end of the session. Okay, clear hai? So we have discussed today we have discussed the simple EOQ model. We have discussed the basic or simple and try to solve as many questions as you can ताकि आपको कोई डाउट ना हो. And whatever logic is behind, देखो, if this logic is understandable, then आपका बाकी सारा models also we can easily understand. But the thing is, the basic EOQ आपको आना चाहिए. Question सबसे ज्यादा the most highest chance is that you'll be getting question from the basic EOQ model. वहीं से questions आते हैं. Clear है? Right? So this is all about today's session about the basic EOQ model that we have seen. ठीक है, तो मैं एक बार फॉर्मूला फिर से लिख देता हूं. आज we have seen the basic EOQ model, right? And in that we have seen how to calculate the economic order quantity, that is 2DCO by CH, root of this. ठीक है, और if I want to calculate the optimum orders, optimum number of orders, right, that will be equal to N star, that is capital D by Q star, that is orders per year. ठीक है, if they're asking the optimum cycle time, optimal time duration or cycle time, that is T star, that is equal to Q star by small d या capital D, that depends कि question में they're asking in year per or in days. If they're asking in days, then we'll be using this will be days per order. ठीक है? If they're asking in year, then this small d will be replaced by capital T. That's it. ठीक है? So this formulations will be again repeated in other models also. बाकी models में भी the same formulation will be repeated again and again. So for that only I've invested maximum amount of time इस model में, so as to have a better understanding. Clear है? Fine. चलिए, so that's it from my side. I hope you all enjoyed this basic EOQ model पे ये session. ठीक है? कल फिर मिलेंगे. We'll be again meeting at 7 PM. 7 बजे आना है, सेम टाइम है, and we'll be discussing one more concept of industrial engineering that will be very helpful for your GATE 2025 preparation. छोटा सब्जेक्ट है, important topics में ही मैं important topics ही I am taking, so as in less time you are able to cover this subject. Clear? Fine. So that's it from my side. I hope all of you have registered yourself on the Resultant platform or you have subscribed to this particular YouTube channel, क्योंकि यहाँ पे you will be getting all the free sessions for your all the different preparations, not only for GATE or ESE. उसके अलावा भी SSC, JEE, RRB, JEE और AE examination we'll be discussing. The practice sessions will be there. ठीक है? So don't worry, everything is being lined up. तो बस only thing you have to do is subscribe to this channel. Okay? फाइन. हाँ, स्मॉल डी और कैपिटल डी में डिफरेंस. स्मॉल डी होता है आपका डिमांड रेट. अब ऑलरेडी वी हैव टेकन दिस डिस्कशन. मैंने यहाँ पे ना इसलिए पहले ही एग्जांपल दे रखा था. ठीक है? आई हैव ऑलरेडी टेकन एंटायर डिस्कशन व्हाट इज स्मॉल डी, व्हाट इज कैपिटल डी. ठीक है? विद सम वैल्यू आल्सो. राइट? तो आप एक बार ना देख लीजिएगा. मैंने वैसे स्मॉल डी इज डिमांड रेट. जैसे लेट अस सपोज एनुअली 12,000 यूनिट्स इज रिक्वायर्ड. ठीक है? 12,000 यूनिट्स इज रिक्वायर्ड. तो कैन यू टेल मी कि एक दिन में कितने यूनिट्स का रिक्वायरमेंट होगा? अगर इफ आई से 12,000 यूनिट्स इज रिक्वायर्ड, लेट्स से कैपिटल डी इज 12,000 यूनिट्स पर ईयर. दिस इज योर एनुअल डिमांड, एक साल का डिमांड. ठीक है? इफ आई वांट टू कैलकुलेट व्हाट इज द डिमांड रेट, डिमांड रेट मींस डेली और वीकली और मंथली. डिमांड रेट लेट्स से पर डे बेसिस, यूनिट्स पर डे. ठीक है? तो कितना होगा? बस यू हैव टू डिवाइड बाय 365. दैट्स इट. दैट्स व्हेन दिस मच ऑफ यूनिट्स विल बी रिक्वायर्ड पर डे बेसिस. दैट्स इट. ठीक है? तो आई हैव टेकन वन एग्जांपल आल्सो, ताकि आपका डाउट जो है वो और क्लियर हो जाएगा. राइट? सो डोंट वरी अबाउट दैट. So that's it from my side. Please do like this session. अगर नहीं किया तो जल्दी से कर लीजिए and subscribe to this channel and make sure everyone is sharing this video and saving to your playlist, so as whenever you want to revise this topic, you can do revise by looking at this session in a very crisp manner. Okay? Thank you. Bye-bye. Take care. Stay safe and enjoy your preparations with Resultant. Thank you. Bye-bye. Take care.